So how far we have completed in the last lecture? We are dealing with the numerical truss. Okay. Problem, I will draw the diagram. You tell me up to which joint we have covered. First of all, I will draw the diagram. So the this if it is completed, then let me also know. I think you are having the diagram with you. The triangular type truss. Okay, three equilateral triangles. Okay, so this is the truss which we were solving in the last lecture. Now directly I will show here the reactions. Here you know the roller support was given and the reaction is vertical reaction because roller is resting on the horizontal surface. Here two reactions are there because it is hinge support VA and HA. And the loading, if we talk about loading on this joint here, here is the load of 40 kilonewton, 30 kilonewton, then horizontal load of 10 kilonewton. Then here is again one more load of 20 kilonewton. So I will write this is 40 kilonewton, 30 kilonewton, 10 kilonewton. Then this is 20 kilonewton. Here is RE. Here it is VA and HA. I think we have calculated the reactions. Okay. So let me know the values quickly. What was the value of RE?
58.18.
58.18. Okay, RE is 58.18. What is the value of VA?
31.82.
31.82. And what is the value of HA?
10.
10.
10 kilonewton. So directions of the reactions which we have shown are correct. All the answers which we got all are positive or anything is negative?
All are positive.
Okay, so the directions which we have shown over here are correct. Our assumed directions are correct. Now I will give the name to this truss. So here it is point A, B, then C, D, E, F, and G. Okay, each side of the truss is 3 meter. Okay, every side AB, BC, BD, AD, whatever it may be, all the sides are 3 meter. So now let me know up to which joint. Joint A, we have solved the joint A.
Yes, sir.
Yes, sir.
Joint A आपण solve केले. So let me know the final value of FAB. What was the value?
36.74.
36.74. 36.74. Compressive or tensile?
Compressive.
Compressive. So I will show here. It is compressive. So arrow is towards the joint. Arrow is towards the joint. Then FAD. What is the value?
8.37.
8.37. Compressive or tensile?
Tensile.
Tensile.
Okay, tensile. So arrow must be away from joint. So arrow will be like this. Okay, it must be away from joint. Okay, after that, which joint we have solved?
B joint.
B. Okay, so joint B. So in joint B, what is the force in member BC? This is
13.66.
13.66.
Yes.
Compressive.
13.66 kilonewton compressive. Okay. So here it is compressive. Arrow must be towards the joint. Arrow is towards the joint. Then what is the force in member BD?
9.44.
9.44.
9.44 kilonewton. Compressive tensile?
Compressive.
Compressive. So this is also compressive. Arrow is towards the joint. Okay. So after this, any joint we have solved?
No.
Okay. So now we have solved joint A, joint B. Now move to the next joint. Now here you can move to the next joint, joint D. Okay. Or you can go for joint G also. And but you cannot go for joint C because here CD, CE, and CF, three unknowns are there. So we cannot solve joint C. So it is better we will think about this joint D. So now I will draw the free body diagram of this joint D. First of all, I will draw the vertical line, then horizontal line. So here is the joint D. So this member DE, DE is the horizontal member. We don't know the force in member DE. So I assume it as a tensile. I will assume it as a tensile. So this is the force in member DE, tensile FDE. Then DC, it is also tensile because we don't know the force in member DC. So these two forces I have shown over here. This is FDC, this is FDE, and we know that this angle is 60 degree because every side is 3 meters. So this is equilateral triangle. So here the angle is 60 degree. Now you can see in the free body diagram, when we draw the free body diagram, see this is the free body diagram. In this portion you have to look. Now see here the member BD. Member BD is compressive. Compressive means arrow is towards the joint. Arrow is towards the joint. So I will draw that force BD. It is like this. This is the force. In this way I can show BD. It is compressive, so arrow is towards the joint. So now here also you know that this angle is also 60 degree. Angle for BD it is also 60 degree. So I will mark here. This angle is also 60 degree. Then this member DA. Now here you can see arrow is away from joint. Okay, AD is tensile. So arrow is away from joint. Here we have calculated AD already, which is tensile. So this arrow is away from joint. So same I will show over here. So this is arrow away from joint. This is FDA. Force in member DA, but we know the force. So I will directly write the value. Okay, for these two forces. So we know the value of AD, it is 8.37 kilonewton. So this is 8.37 kilonewton. And the value of DB or BD, it is 9.44. So this value is 9.44 kilonewton. So this is the free body diagram. Now we will resolve the inclined forces first. So if I resolve this one, so we will resolve from here. One line parallel to Y, another line parallel to X. So the another component is parallel to X in this way. So here I will write the name. So this is FDC. This is FDC. Cos ka sign.
Sine.
Sine. And angle is 60 degrees. So it is sine 60. And this is FDC cos 60. Then again this 9.44 kilonewton. If you resolve this one also, then one component is along this y-axis. So this component will be like this here. Okay. And because this is compressive force, and the second component will be like this. Now if you see, this angle is 60 degrees. So horizontal component will be cos and vertical will be sine. So this is 9.44 sine of 60. And this is 9.44 cos of 60. Okay, 9.44 cos of 60. So now apply summation Fy equal to 0. Now if I apply summation Fy equal to 0, summation Fy equal to 0, upward forces are positive, downward forces are negative. So in the summation Fy, now what you will get? So you will get FDC sine 60, which is moving upward. FDC sine 60. Then this 9.44 sine 60, which is moving downward. Okay. So here minus 9.44 sine 60. Okay, so this is minus. Then what is remaining? What else is remaining? Nothing. Okay, so this is equal to 0. Therefore, FDC is equal to
9.44.
9.44. Positive or negative?
Positive.
So this is tensile. Okay. So FDC is tensile. So our assumed direction is correct. We have assumed that FDC is tensile and we got positive answer. So our assumed value is correct. So here FDC. So this is DC tensile. So arrow must be away from joint. So in this way we are going to show the arrow away from joint. Then apply summation Fx equal to 0. Okay. So if you apply summation Fx equal to 0, then the summation Fx equal to 0. So here you can see horizontal forces now 8.37 moving towards left. So this is minus. Then this component, which is 9.44 cos 60 is moving towards right. So this is plus. Again, this component, FDC cos 60, this is also plus moving towards right. Okay. And FDE, it is also moving towards right. So this is also plus. So I will write everything in the equation. So here, first of all, minus 8.37 plus 9.44 cos of 60 degree plus now see here FDC cos 60, it is moving towards right. FDC cos 60, what is the value of FDC? It is 9.44. Okay, so plus FDC cos 60. First of all, I will write here FDC cos 60 plus here this FDE, this is also moving towards right. So plus FDE is equal to 0. So therefore, here it is minus 8.37 plus 9.44 cos of 60 plus FDC is also 9.44 cos of 60 plus FDE is equal to 0. So calculate this and let me know the answer for FDE.
One 1.05
1.05 positive or negative?
positive.
1.05 kilonewton. Okay, so you have got the positive answer.
Negative.
sir.
निगेटिव्ह येते का? हे
Yes, sir.
1.5 बरोबर आहे ना?
Yes, sir.
So this is negative. Now it is correct.
Yes, sir.
Okay. So FD is equal to minus 0.15 kilonewton. Means what? FDE is not tensile. We have assumed it tensile. It is not tensile. The answer is 1.05 kilonewton, but it is compressive. So I will show the arrow over here in the diagram. So FD is compressive, so arrow must be towards the joint. So in this way, we will show the arrow towards the joint. Okay. Now after D joint, if you go to E joint, so at E joint, how many unknowns are there? EC, EF, and EG. So you cannot solve joint E. Okay. So if you go to joint C, so at joint C, CE and CF, only two unknowns are there. So we can solve joint C. Okay. We can solve joint C, and we know that these angles. This angle is 60 degree for CF, and this angle is also 60 degree for CD. Okay, for CD. So now I will draw the free body diagram of this joint C. So free body diagram of joint C. So on joint C, there is a load of 30 kilonewton which is acting. Downward load, this is 30 kilonewton. Then two horizontal members are there here, CF and CB. So those two members we will show, CF and CB. CF, CB. So this is F, CF, F, CB. Then inclined members are also there. This member CD. Okay, CD and CE. So compressive or tensile. So CD is tensile. CD is tensile. Now we will write the values. CB means BC 13.66. Okay. Now here you can see member CB. If you see this arrow, it is towards the joint. So this is compressive. So CB is 13.66 compressive. So FCB, it is compressive. It is like that. And its value is 13.66. So its value is 13.66 kilonewton. The next is this. This arrow is away from joint. So this is tensile, CD. So CD, what is the value? CD is 9.44. 9.44 kilonewton. And this angle is 60 degree. Then finally, here, this member, CE. Okay, FCE. And this angle is also 60 degree. First of all, resolve the forces. So one component, so I will draw the components here on the force. Okay. So one component will be in this direction. Another component will be in downward direction. Okay. So here I will write, this is 9.44. So cos sine. This is 9.44 sine असणार आहे का cos असणार आहे हा component?
Sine.
Sine. Okay, it is sine 60. And this will be 9.44 cos 60. Okay, so I have shown the components here on the force. हे समजते काय केलेलं हे components actually कुठं पाहिजेत? इथं पाहिजेत दाखवलेले बरं का? Technically, these components, this horizontal component will be here, and this vertical components will be shown here because this is the point of application. But for our understanding, I have shown it over here. हे समजतंय ना असं दाखवलेलं?
Yes, sir.
Yes,
हा,
sir.
नाहीतर तुम्ही म्हणणार मागच्या प्रॉब्लेम मध्ये मागच्या जॉईंटला एकदा इथं दाखवताय, परत इथं दाखवताय, मग ते कसं? तर हे तुम्हाला समजायसाठी इथं दाखवलंय. ऍक्च्युअली करेक्टली जर मला दाखवायचं असलं हे, इफ आय वॉन्ट टू शो इट करेक्टली, देन इट शुड बी ओव्हर हिअर, दिस कॉम्पोनंट, अँड दिस कॉम्पोनंट मस्ट बी हिअर ऍट दिस पॉइंट. Okay, this is the correct way of resolution, and in this way only you should do the resolution. But here for the understanding purpose, I have shown the resolution like this on the force itself, so that it will not get mixed with the resolution count with the component of other forces. Again,
असं काढलं तर मार्क देणार ना?
काय झालं?
पेपर मध्ये रिझोल्युशन असंच काढलं तर मार्क्स मिळतात ना? जर तुम्ही आता
मिळतात की.
काढले ते.
मिळतात की. तुम्ही कॅल्क्युलेशन व्यवस्थित लिहा. ह्या डायग्रामला मार्क्स नसतात. ओके, ह्या डायग्रामला मार्क मिळत नाहीत, लक्षात घ्या. ही डायग्राम तुम्ही का काढता? तर आपल्याला त्याची फ्री बॉडी डायग्राम मिळाल्यावर आपल्याला त्याला अनालाइज करायला सोपं जातंय. ओके, even though if you don't draw the free body diagram of the joint and directly you have solved that joint and you got the correct answers, then also you will get the marks. Okay, but generally it is advisable that you have to draw this diagram, and this diagram is for our simplification. ओके, त्याच्यामुळे काय प्रॉब्लेम नाही, तुम्ही असं दाखवू शकताय, पण हे ऍक्च्युअली इथं असायला पाहिजे. एवढं फक्त लक्षात ठेवा, कॉन्सेप्ट विसरू नका याचा फक्त. Okay, this is for our understanding. It is for us for the simplification. So now FCE, it is also inclined at an angle of 60 degrees. So again, I will resolve that. So one component, I will show it like this. Another component. So I will recommend you. बघा, माझं रेकमेंडेशन काय ते नीट ऐका. ज्या वेळेला तुम्ही ट्रस्टचा प्रॉब्लेम सोडवताना एक्झाम मध्ये किंवा ट्रस्ट सॉल्व्ह करत असताल वगैरे किंवा जॉईंट इक्विलिब्रियम घेत असताल, तर त्यावेळेला असं घ्या. असं का सांगू का? कारण की हे ट्रस्ट सॉल्व्ह करताना आपल्याला नॉर्मली मेथड ऑफ जॉईंट्स मध्ये दोनच इक्वेशन लागतात, एक समेशन एफ एक्स आणि समेशन एफ वाय. तिथं मुवमेंटचा आणि डिस्टन्सचा कुठं काय संबंध येत नाही आपल्याला. जॉईंट सॉल्व्ह करताना म्हणतोय, रिएक्शन कॅल्क्युलेट करताना मुवमेंट घ्यावी लागते. जॉईंट सॉल्व्ह करताना फक्त दोनच इक्वेशन आपण वापरतो, एफ एक्स आणि एफ वाय. तर त्या ठिकाणी तुम्ही असं दाखवत असाल तर चालून जाते, काही प्रॉब्लेम येत नाही. पण बीम्सचे प्रॉब्लेम किंवा फर्स्ट युनिटचे प्रॉब्लेम, त्या टाईप तिथला कुठला प्रॉब्लेम असेल तर हे रिझोल्युशन दाखवताना नेहमी पॉइंट ऑफ कॉन्टॅक्ट पासूनच दाखवा. समजतंय? नेहमी कुठून दाखवायचं? पॉइंट ऑफ कॉन्टॅक्ट. का? त्याचं रिझन काय? तर आपण फर्स्ट युनिटमध्ये आणि सेकंड युनिटमध्ये समेशन एमचं इक्वेशन खूप वेळा वापरलेलं आहे, टू फाइंड आउट रिएक्शन, टू फाइंड आउट फोर्सेस. तर जर हे कॉम्पोनंट तुम्ही व्यवस्थित त्याच्या पॉइंट ऑफ कॉन्टॅक्ट पासून दाखवले नाहीत, तर तुमचं परपेंडिक्युलर डिस्टन्स मुवमेंट घेताना जे परपेंडिक्युलर डिस्टन्स तुम्ही घेता ना, त्याच्यामध्ये चूक होऊ शकते. ओके, सो टू अवॉइड दॅट, whenever you will see the problem is of truss, and that too you have to solve that truss by method of joints, then only you can show it like this. It will be simpler for you. Otherwise you should show by our conventional method. इथं कसं मी दाखवलेत बघा कॉम्पोनंट, अशीच दाखवायला तुम्ही पाहिजेत. Is it clear?
Yes, sir.
Okay. So now moving further, this is FCE. This is also FCE. This will be cos 60 and this will be sin 60. So now we need to solve this. So first of all, I will apply summation. Let us apply Fy equal to 0. So when you apply summation Fy equal to 0, then minus 30, this is moving down. This is also moving down. Minus 9.44 sin 60. Then this is also moving down, minus FCE sin 60 is equal to 0. So therefore, FCE is equal to, calculate this and let me know the answer.
minus 44.07 kilonewton.
Minus plus
Minus.
minus, okay, minus 44.08,
08.
okay, kilonewton. So this is FCE. So you have got the minus answer. So I will write here FCE is equal to 44.08 kilonewton compressive. ओके, मग याचा अर्थ काय झाला, FC आपण कसं दाखवलंय, टेन्साईल. तर आपण काय कसं दाखवायला पाहिजे, हे कॉम्प्रेसिव्ह दाखवायला पाहिजे. ओके, पण आपल्याला आता इथंच डबल डायग्राम काढत बसायची नाहीये जॉईंटची, म्हणून आपण काय करणार, तसंच यूज करू त्याला. फक्त मग तसंच यूज करताना काय घ्यायची व्हॅल्यू, कुठली व्हॅल्यू घेणार आता कॅल्क्युलेशनला सीईची? पुढच्या इक्वेशन मध्ये
निगेटिव्ह
मायनस मधली व्हॅल्यू घ्यायची. कारण का, तर कॉम्प्रेसिव्ह आलंय, आपल्याला माहिती आहे, तरी सुद्धा आपण डायरेक्शन चेंज करत नाहीये. हे त्याच्या पाठीमागचं रिझन आहे. सो अंडरस्टँड द रिझन्स वाय वी आर डुईंग इट लाईक दॅट. So now I will apply summation fx equal to 0. So what I will get now, this 13.66, it is plus moving towards right. Then plus this FCF, it is also moving towards right. Then minus this 9.44 cos 60, 9.44 cos of 60 degree. Then again this is plus FCE cos 60 is equal to 0. Okay, all this is equal to 0. So now here it is 13.66 plus FCF will be as it is minus this 9.44 cos of 60. It is plus, but FCE minus, its value is minus 44.08 cos of 60, which is equal to 0. Therefore, force in member CF what is the answer?
13.09 kilonewton
Plus or minus
plus
13.09 kilonewton. You have got plus positive answer, so it is tensile. So CE is compressive and CF is tensile. So I will write here CE is compressive. So CE, this is compressive. Arrow is towards the joint if compression is there. And CF is tensile, so arrow is away from joint. Arrow is away from joint. Okay. Okay. Now you can solve joint E also and joint F also and joint G. So we can solve now joint F. So let us solve the joint F. So free body diagram of joint F. So CF, it is tensile. FE is also tensile, FG is also tensile. You know that here you can see the angles. If I do it like that, okay, because this force itself is a horizontal force. The horizontal force. So here you can see if this angle is 60 degree, this angle is also 60 degree, and this angle is also 60 degree. So here CF, it is tensile. Just a moment. So CF, it is tensile, and we will show the compression. Just a minute. Okay. So here, FE and FG we will assume as tensile, and CF it is also tensile. So this is tensile, also tensile. Is also tensile. Okay. So we know the value of one of the force. So here we know the value CF. So the value of CF is, I think we have calculated. Okay, 13.09. Okay, so this is 13.09. This value is 9. 10 kilonewton is the horizontal force. 13.09. So this is 13.09 kilonewton, and a horizontal force is also there. Here it is of 10 kilonewton. This force, it is of 10 kilonewton. Angle for both the forces with horizontal, this is 60 degree. This angle is also 60 degree. Here it is FG. This is force in member FE. Correct. So this is the member FE and FG. So we will solve this joint now. We have to resolve the forces first. So if I do the resolution, then see the vertical component, horizontal component. Here also vertical component, and then horizontal component. So here F force in member FE sin theta, FE sin theta, sin 60 cos 60. For this, here it is force in member FG, FFG sin 60. This is FFG cos 60. This is FFG cos 60. Okay. Now apply summation Fx equal to 0 first. Apply summation Fx equal to 0. You write the equation. What is the equation for summation Fx equal to 0? So now when you apply summation Fx equal to 0, then the equation will be minus 13.09 because it is moving towards left. This 10 is also towards left, minus 10. Then again minus force in member Fe cos 60 plus okay, Fg cos 60 is equal to 0. Now if you rearrange the terms, then what you will get? So if I write over here, this is Fg cos 60, which is positive, minus force in member Ffe cos 60 is equal to, now this is 13.09 plus 10, it is 23.09. So minus, and on that side it will become plus. So 23.09. This is my equation number 1. This is my equation number 1. Now if I apply summation Fy equal to 0, if I apply summation Fy equal to 0, then what I will get here, you can see this force is downward. So it is minus Fef sorry, minus f fe sine 60 minus f fg sine 60, both are downward. This component, vertical component, is also downward, is equal to 0. Okay. So therefore, if I rewrite the equation, then it is f fg sine 60, obviously it is minus force in member fe sine 60, it is equal to 0. This is my equation number 2. This is my equation number 2. Now solve these two equations on the calculator. Okay, solve these two equations on the calculator. You will directly get the answer. You will directly get the answer. And let me know the answer. Directly you will get the answer for these two equations. Do you know how to solve these equations on the calculator?
No, sir.
माहितीये का, सांगू कसं सॉल्व करायचं कॅल्क्युलेटर वर?
सांगा सर.
Okay.
सांगा.
Okay, from basic I will tell you. First switch on your calculator. Then search the mode button. Mode कुठे आहे बघा. मिळालं का mode button?
Yes.
Sir.
MOD. हा. In that mode, go to equation mode. Equation mode सापडते का बघा. कसलं कॅल्क्युलेटर आहे तुमच्याकडे? मी जे दाखवतोय असंच आहे का? असं कॅल्क्युलेटर आहे?
Yes, sir.
हा, मग असं जे मी दाखवतोय तुम्हाला कॅल्क्युलेटर, हे कॅल्क्युलेटर आहे. दिस कॅल्क्युलेटर इज FX991MS, लाईक दिस. ओके.
सर माझ्याकडे 100 mAh त्यात
एकूण-
COMP
असते 100 mAh मध्ये पण आहे. ओके.
त्याच्यात COMP आणि CMPLX दोनच ऑप्शन येतात.
अजून एकदा दाबा की. आलं का पुढं SD REG बेस दिसलं का?
येस सर.
अजून एकदा दाबा. आलं का इक्वेशन? एक इक्वेशनच्या खाली एक लिहिलंय का?
हो सर.
हा. So I will tell you first, when you switch on your calculator, there is mode button. So you press that mode button 3 times, 1, 2, and 3. If you press it 3 times, then you will see that there is EQN is written on your screen. Below that one number is there. Then secondly, MAT means matrix. Below that 2 number is there. And third is VCT. Below that 3 number is there. हे दिसते का स्क्रीनवर आलेलं?
येस सर.
आलंय का सगळ्यांच्या? काय मला आवाज येईना तेवढ्यांचा, एक दोघच बोलायला लागलेत. बाकीच्यांचं काय
Yes, sir. आले.
आलंय? ओके. नाव EQN च्या खाली एक लिहिलंय ना, तर ते एकला प्रेस करा. केलं का?
Yes, sir.
हा, काय विचारते तिथं? अननोन्स 2 किंवा 3. हा, किती अननोन्स आहेत आपल्या इक्वेशन मध्ये? हाऊ मेनी अननोन्स आर देअर? कशा कशाची व्हॅल्यू पाहिजे आपल्याला? वी वॉन्ट द व्हॅल्यू ऑफ फोर्स इन मेंबर FG and FE. So how many unknowns are there?
2.
2 unknowns are there. So press 2 now. केलं का?
Yes,
येस सर.
काय आलं स्क्रीनवर? A1 इज इक्वल टू क्वेश्चन मार्क आलं का? A1 च्या पुढे क्वेश्चन मार्क.
हो सर.
हा, आता तुम्हाला जरा इथं मी बोर्डकडे बघा. कॅल्क्युलेटर असंच ऑन राहू द्या. बोर्डकडे बघा. हे A1 B1 काय ते तुम्हाला सांगतो. So in the mathematics you learn that what are the formats of the equation. Okay, if the quadratic equation is there, then it is in the form ax square plus bx plus c is equal to 0. This is called as quadratic equation. Okay, quadratic equation. Linear equation you say, you know that y is equal to mx plus c, that you have learned. One more form of the linear equation is there, that is ax plus by is equal to c. One more form of the linear equation is there, ax plus by is equal to c. Okay, if 2 equations are there, then this form we can write, it is like this: a1x plus b1y is equal to c1, and second equation a2x plus b2y is equal to C2. So this is called as the linear equation with 2 unknowns. because C1, C2 are the constants and X and Y are the variables. X and Y are the variables. After solving this, we will get the value of X and Y. Okay, so same thing is here in our equation. Same thing is here in our equation. So बघा आता हे F FG म्हणजे हे झालं आपलं X. FEF म्हणजे हे झालं आपलं Y. ओके, हे 23.09 आहे, हे म्हणजे आपलं C1 झालं. दिस इज कॉल्ड ॲज C1. हे जे तुमचं cos 60 आहे ना, दिस इज नथिंग बट दिस इज युअर A1. दिस इज युअर A1 अँड म्हणजे ह्याच्यामध्ये A1 काय असणार आहे तुमचं, तर A1 इज इक्वल टू cos of 60. Cos 60 is your A1. Then your B1 will be, B1 is equal to FEF हे Y आहे, म्हणजे राहिलं काय cos 60, पण हे काय मायनस. So your B1 is minus cos 60. Your B1 is minus cos 60 and your C1 it is 23.09. This is for equation number 1. This is for equation number 1. Now if I go to equation number 2, equation number 2 म्हणजे काय असणार आहे A2, then B2 and C2. Okay, so A2 ची व्हॅल्यू काय इथं, हे विथ मायनस साइन घ्यायचं बरं का, मायनस मायनस हे जे FG आहे हे आपलं X आहे आणि EF काय आपलं Y आहे. इथं कॉन्स्टंट काय आहे C2 ची व्हॅल्यू काय इथं 0. सो आवर कॉन्स्टंट इज 0. It is minus sin 60 A2 and B2 is also minus sin 60. So these are the values for equation 2. Okay, मग आता कॅल्क्युलेटर वरती तुमच्या A1 विचारलंय. So A1 ची व्हॅल्यू किती लिहिणार, cos of 60. So type there cos 60. केलं का टाइप cos 60? Yes, no?
Yes, sir.
मी जोपर्यंत सांगत नाही तोपर्यंत पुढचं एकही बटन दाबायचं नाही. जेवढं सांगतोय तेवढं केलं की लगेच यस म्हणून सांगा. A1 is equal to A1 क्वेश्चन मार्क आलं होतं. In that you have put the value of A1 is equal to cos 60. So cos 60 टाइप केलं का तुम्ही तुमच्या स्क्रीनवर?
Yes, sir.
Yes, sir.
प्रेस इक्वल टू बटन एकदाच दाबा.
Yes, sir. B1 आलं.
हा B1 ची व्हॅल्यू किती आहे?
Minus cos 60.
हा, नाव एंटर मायनस cos 60. ओके, अगेन प्रेस इक्वल टू
C1
C1 ची व्हॅल्यू किती आहे?
23.09.
हा, सो एंटर 23.09. अगेन प्रेस इक्वल टू A2 ची व्हॅल्यू किती आहे?
minus sin 60.
हा, एंटर दॅट व्हॅल्यू मायनस साइन 60. अगेन प्रेस इक्वल टू, सो इट विल आस्क यू द व्हॅल्यू ऑफ B2. सो B2 इज अगेन मायनस साइन 60. Okay. Then again when you press equal to, it will ask you the value of C2. So value of C2 is 0. एंटर केली का C2 ची व्हॅल्यू 0?
Yes, sir.
प्रेस इक्वल टू
23.09.
काय दाखवते स्क्रीनवर ते सांगा. X इज इक्वल टू का Y इक्वल टू?
X is equal to
हा, X इज इक्वल टू 23.09. मग आपण X कशाला मानलं होतं?
FG.
हा, FG. सो फोर्स इन मेंबर FG किती मिळाला आपल्याला? फोर्स इन मेंबर FG इज इक्वल टू इट इज 23.09. वी हॅव गॉट द पॉझिटिव्ह आन्सर. सो दिस इज टेन्साईल. आता मग Y ची व्हॅल्यू कशी मिळणार?
minus
हा,
0.
काय करा बघा, तिथे एक मोठं बटन आहे तुमच्या कॅल्सीवर, कॉपी म्हणून लिहिलंय बघा, त्याच्यावर कॉपी आणि रिप्ले दिसतंय का मोठं
Yes, sir.
बटन? हा, तिथे खाली जायचं ऍरो आहे बघा, खालच्या ऍरोला प्रेस करा. केलं का?
Yes, sir.
हा, काय दाखवतंय स्क्रीनवर?
Y is equal to minus 23.09.
Okay, so now it is showing on the screen y is equal to minus 23.09. So y is member EF. So force in member EF or FE is equal to, it is minus 23.09. So it is 23.09 kilonewton. I will say it is compressive. I will say that it is compressive. Okay. Is it clear now? How to solve the equations?
Yes,
Yes,
sir.
sir.
समजलं ना? हे फॉर्मॅट तुम्हाला माहित पाहिजे. दिस फॉर्म. So just you have to enter the values of the constants A1 आणि असे तुम्ही 2 unknowns आणि 3 unknowns पर्यंत सोडवू शकताय तुमच्या कॅल्क्युलेटर वरती डिरेक्टली. ओके. मग आता मोड बंद बाहेर कसं यायचं परत? वापरता यायला लागलाय का कॅल्क्युलेटर दुसऱ्या कुठल्या कामासाठी? करा बरं कॅल्क्युलेशन 2+2 करा बरं, होतंय का?
नो सर.
नाही होत ना? मग आता काय करायचं सांगतो. हा?
मॉड प्रेस केल्यावर कॉम्प येते, त्याला 1 क्लिक केले की करेक्ट होते.
ओके, तसंही चालतंय. किंवा दुसरी एक गोष्ट आहे का, ज्या वेळेला तुम्ही कॅल्क्युलेटर यूज करत असता, सी नाउ यू आर युझिंग द कॅल्क्युलेटर फॉर डिफरंट सब्जेक्ट्स लाईक मॅथ्स, फिजिक्स, युअर अप्लाइड मेकॅनिक्स, व्हॉट एव्हर इट मे बी. समटाइम्स व्हॉट हॅपन्स की तुम्हाला वेगवेगळ्या मोडमध्ये जाऊन काम करावं लागतंय. सो वेन यू आर फाइंडिंग आउट द डिटर्मिनंट ऑल्सो यू कॅन डायरेक्टली फाइंड ऑन द कॅल्क्युलेटर. मॅट्रिक्स इनव्हर्स ऑल्सो यू कॅन डिरेक्टली फाइंड ऑन द कॅल्क्युलेटर. ओके, तुम्हाला डायरेक्ट कळतंय मॅट्रिक्सचा इन्व्हर्स काय आहे इथं. आता जसं इक्वेशन सॉल्व्ह झालं ना सेम. सो मग यावेळेला काय होतंय की यू मे एंटर इन अ डिफरंट मोड. आणि मग वेगळ्या मोडमध्ये जर तुम्ही कॅल्क्युलेशन करायला गेलं तर ते होत नाही. तर त्यासाठी काय करायचं, शिफ्टचं बटन दाबायचं एकदा, त्यानंतर मोडचं बटन दाबायचं. शिफ्ट दाबून मोडचं बटन प्रेस करा. काय दिसतंय सांगा मला समोर.
MC1 मोड
हा,
ऑल
आणि ऑल दिसतंय ना? ऑलच्या खाली काय नंबर आहे?
3.
हा, मग ऑलच्या खाली 3 ला प्रेस करायचं. काय दिसतंय स्क्रीनवर?
रिसेट ऑल.
रिसेट ऑल आलं का? इक्वल टू दाबा. परत आलं का रिसेट ऑल?
येस
परत एकदा इक्वल टू दाबा.
झालं सर.
झालं का? 0 आलं का स्क्रीनवर?
येस सर.
Have you seen 0 on the screen? So in this way you can come out from any mode. जर तुम्हाला ते कळलं नाही, कॉम्प आणि कॉम्प्लेक्स बिम्प्लेक्स दुसऱ्या नंबर मध्ये गेलात तुम्ही, तर सरळ शिफ्ट दाबून मोड दाबायचं आणि 2 वेळा 3 प्रेस करायचं. पहिल्यांदा 3 प्रेस करायचं, इक्वल टू दाबायचं, परत एकदा 3 प्रेस करायचं, इक्वल टू दाबायचं. सो यू विल कम बॅक इन टू द ओरिजिनल मोड. इज इट क्लिअर नाउ? तुम्हाला मॅथ्स मध्ये आहे का डिटर्मिनंट कॅल्क्युलेट करणे, इनव्हर्स कॅल्क्युलेट करणे, मॅट्रिक्स आहे का?
येस सर.
मग तुम्हाला तर 2 मिनिटात आन्सर मिळत असेल कॅल्क्युलेटर वरती.
येस सर.
येतं ना कॅल्क्युलेट करता? शिकून घ्या, वाचा जरा. ओके, सो इन दिस वे आय होप नाउ यू अंडरस्टूड दिस. आता मी परत रिपीट करणार नाही बरं का, हाऊ टू सॉल्व द इक्वेशन्स. यू नाउ प्रॅक्टिस बाय युअर ओन हाऊ टू सॉल्व. घ्या कुठलेही 2-4 इक्वेशन्स घ्या आणि कॅल्क्युलेटर वरती सॉल्व्ह करून बघा. घ्या असे 2x + 3y = 4, देन 4x + 6y = 9. जे इक्वेशन्स तुम्हाला डायरेक्ट असे सॉल्व्ह करता येतील असे घ्या आणि मॅन्युअली आणि कॅल्क्युलेटर वरती सेम आन्सर येते का नाही जरा चेक करून बघा. सो दॅट इट विल बूस्ट युअर कॉन्फिडन्स. अँड देन also there will be the practice of solving these equations. Okay, so finally you have to prepare the table. So table is your homework. ह्याचा या प्रॉब्लेमचा टेबल तयार करायचा. टेबल मध्ये काय असणार आहे? मेंबर. आफ्टर दॅट force in kilonewton, and after that
नेचर ऑफ
nature of force. Okay, so that you have to prepare by your own. तुम्ही स्वतः हे तयार करा. In the next lecture now we will begin with method of sections. So now enough problems are there on method of joints. हीच प्रोसिजर आहे जी तुम्हाला रिपीट करायची आहे. Whatever may be the problem, you have to repeat the same procedure. If the supports are given, first of all find out the support reactions, then find out the joint which is having only 2 unknowns. Initially assume that the forces in the member are tensile forces, and after calculation if you get the positive answer, keep them as tensile as it is. If you get negative answer, then change their directions. Okay, so that is the thing. And by using the equations of summation fx and summation fy, you have to solve the truss by method of joints, by using only these two equations in the joint equilibrium. Okay, and after that, finally, you have to prepare the table in which all the members are mentioned, forces in kilonewton are given in front of them, and you have to write there what is the nature of force, tensile or compressive. So I think sufficient problem we have taken on this. Now you solve the problem by your own. गुगल वरती बघा प्रॉब्लेम्स मिळतात का, पुस्तक असले तर बुक मध्ये सर्च करा. ओके, ट्राय टू सॉल्व मेनी न्यूमेरिकल्स बेस्ड ऑन दिस, सो you will get the practice. And in the next lecture we will start this method of sections. I will tell you how to solve the truss by using the method of sections. So we will stop over here for today.
सर
हा
टीचिंग डायरी वरती व्हिडिओ अपलोड करायचं.
Okay, so right now a workshop is going on in the college. It will take me at least 2 days because today and tomorrow my presentation is there. So day after tomorrow I will upload. Today is Wednesday, no?
Yes, sir.
So Friday, Saturday, 2 days, I think up to Saturday evening I will do it. Okay, किती तारखेपर्यंत अपलोड केलेले आहेत? कुणी बघितले का रिसेंटली टीचिंग डायरी? कुणाला माहितीये का, कुणी बघितलंय का, किंवा कुठल्या लेक्चर पर्यंत अपलोड केलेले, काय कंटेंट वगैरे?
17 तारखेपर्यंत सर केले.
17 फेब्रुवारी पर्यंत केलेत का?
हा,
म्हणजे आज 23 तारीख आहे, म्हणजे किती लेक्चर राहिले आपले? 4 लेक्चर झालेत का तेवढ्यात? 17 फेब्रुवारी पर्यंत केलेले. सो 18, 18, 21, 22, today is 23. So 4 lectures. Okay, so I will upload up to Saturday evening. Okay, so please give me the attendance now. Roll number 1,
Present.
2,
Present, sir.
3,
Present.
4,
Present, sir.
5,
Present, sir.
6,
Present.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12, 13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16, roll number 16, 17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33, 34,
प्रेझेंट सर.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40, 41, 42, 43, 44, 45,
Present, sir.
46,
Present, sir.
47, 48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51, 52,
Present, sir.
53, 54,
Present, sir.
55,
Present, sir.
56, 57,
Present, sir.
58, 59,
Present, sir.
60,
Present.
61. Okay, so I will read the absent roll numbers. Listen carefully. If your roll number is in this absent roll number, then only give me the attendance. Otherwise, if your roll number is not there in this absent number, which I'm now going to call, then don't tell me your roll number. Okay, then you understand that you are already marked here as a present. आता मी जे रोल नंबर सांगतो ते नीट ऐका. रोल नंबर 12, रोल नंबर 40, 42, roll number 42 is present. Okay,
Sir, present, sir.
present. 43, absent. 47, roll number 47, absent. 51, roll number 51, it is also absent. 53 is also absent. 56, roll number 56, 58,
Present, sir.
58 is present. Okay, and then 61 is present. Okay, so we will meet in the next lecture. We will stop now.
Hello, sir. 44 is present, sir.
44 is present. Okay.